The first thing we're going to do today is we are going to review what you should already know about the coordinate plane. Hopefully you are all familiar with the coordinate plane and know that there are 4 quadrants. When you name them, sometimes if you'll think of this like a C because it stands for coordinate plane, that will help you remember where to start to number them. So quadrant 1 is here. Quadrant 2 moves around to the left. Quadrant 3 and quadrant 4. We have our x-axis, which is our horizontal axis. Remember, horizontal is moving left and right. We have our y-axis, which is our vertical axis, and it moves up and down. We have coordinate points, which is your ordered pairs, and those are going to be written as x, y, and they're inside parentheses. And then you have your origin, which is 0, 0, and that is where the x and the y-axis intersect. The first thing we're going to be doing is we are going to be finding the midpoint of a segment. So remember in our notes that we took in Chapter 1, Section 2, we defined midpoint as a point that bisects or divides the segment into 2 congruent segments. So today I'm going to be teaching you a formula that you can use. So you're going to get to flex your Algebra 1 muscles again and do some evaluating expressions. So you can find the midpoint of a segment by using the coordinates, which are the ordered pairs, of its endpoints. So if you look at the diagram below, what you should see is that we have a line segment. We can see that right here. And we have 2 endpoints. We have one that they're calling A and one that they're calling point B. So point A is x1, y1, and point B is x2, y2. So we're going to use that to write our formula. So to find midpoint, you are going to do x1 plus x2 divided by 2. That will give you the x-coordinate of your midpoint. And then you're going to do y1 plus y2 divided by 2 in order to find the y-coordinate of your midpoint. At this point, you may notice that if you add 2 numbers and then divide by 2, really, like if you add the x values and then divide it by 2, really you're just calculating the average of the x-coordinates. And when you add your 2 y-coordinates and divide by 2, once again, you're really just calculating the average of your y-coordinates. So that formula is a little bit more confusing than it really has to be. If you just stack up your coordinates and add them together, and then at the very end divide by 2, then you'll have your midpoint. So here's an example. If you think about this first coordinate as x1, y1, and you think of this second coordinate as x2, y2, you can just line them up like an addition problem, and then you add your x values. So if you look right here, if you have 4 plus negative 8, you get negative 4. And then you add your y coordinates, so 5 plus 1 is 6, and then divide by 2, because you're finding the average. So negative 4 divided by 2 is negative 2, and 6 divided by 2 is 3. And that would be the midpoint between those 2 points. So let's try one together. So I am going to use negative 8, 3 as my first endpoint. So I'm just going to write that as an ordered pair. So I have negative 8, comma 3. And then I'm going to use negative 2, comma 7 as my second endpoint. And I'm just going to add those together. So negative 8 plus negative 2 is negative 10. And then I'm going to add 3 and 7, and I'm going to get positive 10. and then I need to divide that whole thing by 2 to get my midpoint. So I get -5, +5. And that would be my midpoint between those two. So I have segment PQ with endpoint -8, 3 and -2, 7, and the midpoint, which would bisect that, would be -5, 5. Okay, so let's look at example 2. So this one's a little bit different. They give us some different information. So they tell us that we have this line segment XY, and we're looking at the midpoint M. So I'm going to go ahead and start drawing this diagram so that I can talk about it. So I have a segment. I'm going to label it X, Y for my endpoints, and then I have my midpoint M in the center. So they tell us here that X has a coordinate of 2, 7. So I'm going to go ahead and label that right here. So I have 2, 7. And they've given me my midpoint's coordinates. So they're telling me that my midpoint is 6, 1. So this time they're asking me to find the coordinates for Y. So if you look at your picture and you just ask yourself, well, how did they get from X, point X, to the midpoint? And you can just look for that pattern. So how would you get from 2 over to 6 on the x-axis? Well, you would have to add 4. Then you can look and ask yourself, well, how would you get from 7 to 1? So you would be subtracting 6. Then you can just apply that same pattern to get to Y. So if I'm on 6, to get to Y, I would need to add 4. So 6 plus 4 gives me 10, which would be the x value of point Y. Then to get from 1 over to here, I need to subtract 6. So 1 minus 6 is -5. So by extending that pattern, I find out that the coordinates of Y should be 10, -5. At this point, you need to pause the video and you need to complete the next example on your own, and then you can check your work. Okay, so let's walk through this problem. So this one was similar to the problem that we just did together. So they've given us a segment RT. So the first thing I did was draw a diagram and label what the information that they gave me. So R was at -6, -1, and S was at -1, 1. We were looking for the coordinates of point T. So I did the same thing I did on the last one. I looked for the pattern. How did they get from -6 over to -1? Well, they added 5. So I extended that pattern. If I take -1 and I add 5, that would give me an x coordinate of 4 for point T. Then I looked for the pattern from the y values. So if I started at -1 and I get over to +1, I have to add 2. So I extended that pattern. 1 plus 2 would give me a y coordinate of 3 for point T. So my coordinates of T are 4, 3. So now we're going to talk about the distance formula. So in a coordinate plane, you can find the distance D between 2 points, which they're calling x1, y1, and x2, y2. So we're going to use this formula. So we have the square root of x2 minus x1, and then you square that value, and you add it to y2 minus y1 squared. So this should look familiar to you because you've done this before when you worked with Pythagorean theorem. So let's just review Pythagorean theorem real quick. So remember, with Pythagorean theorem, that's the theorem that you used when you had the right triangles, and you called the legs A and B, and your hypotenuse was C. The formula said that A squared plus B squared would be equal to C squared. So if you were actually trying to find the value of C, you would need to take the square root of all of this in order to find that value. So it would wind up being a squared plus b squared under the square root would actually be equal to the value of c. So that's what we're kind of working with right now. So if the distance formula is confusing for you, you can just use Pythagorean theorem instead of the distance formula, especially if they actually give you the coordinates on a graph. So I'm going to show you how to do that now. So if you look at example 3, they're asking me to find the length of segment FG and JK. Then they want to know, well, are those two segments congruent? So if you look at the graph here, you can see that they've actually graphed those segments for me. Now, the way that they're currently graphed, I need to use what I know about the distance formula or Pythagorean theorem in order to find the length, because these are not up and down where I can just count the little boxes. So let's look at JK first. So if I was to take and draw in the triangle that is created there, then I can actually count the lengths of the sides. So you can see that from J down to this point right here would be a distance of 3. You can physically count it. It's 1, 2, 1, 2, 3. And then if you look from that point over to K, it's also 3 units. You can actually count from here 1, 2, 3. So seeing that, I've now formed a right triangle. So I can say that 3 squared plus 3 squared should give me the distance of, or the length of JK, which I'm going to call C squared right now. So 3 squared is 9, plus 9 should be equal to C squared. 9 plus 9 is 18. And if I'm trying to find the value of C, I need to take the square root of that. So remember, the square root of 18, you break this down into its largest perfect square and non-perfect square. So we can then take the square root of that. So the square root of 9 is 3, and then the square root of 2 stays under. So I have 3 square roots of 2 for the length of JK. Now if I look at my other triangle, FG, I'm going to do the same thing. So I'm drawing a triangle on my coordinate plane, and I'm counting the boxes. So from F up to that point is 3. From that point over to G is 4 units. So hopefully you remember that special right triangle that's a 3, 4, 5. So I know that FG has to be 5. So are they congruent? Well, congruent means equal. So those are not equal. So this is not congruent. Now here in example 4, they're asking me to use the distance formula or Pythagorean theorem to find the distance to the nearest tenth from D, which they're giving me 3, 4, which it's on your graph right here, to E, which is at negative 2, 5. Now they've already dashed in the lines for you to show you that right triangle. So leg A, you can see they've labeled it A. The length from there to C, if I count it out, would be 5 units. From C up to D, which they're calling B, leg B, would be 9 units. So this is not one of our special triangles, so I'm just going to go ahead and use the formula. So I have 5 squared plus 9 squared. And I'm going to take the square root in order to find the value. So 5 squared is 25. 9 squared is 81. I'm going to find the sum, which is 106. Now hopefully you recognize that as an irrational number. That is not a perfect square. And if I try to break that down, I know that it breaks down into 2 and 53, neither of which are perfect squares, which they kind of gave you that hint right here because they asked you to give it to the nearest tenth. So you would put the square root of 106 into your calculator, and you would find out that that is approximately equal to 10.3, which would give me the distance between those 2 points. Our last problem here is a word problem, but they do give me a diagram, so I'm going to read that and we're going to solve it. So it says a player throws the ball from first base to a point located between third base and home plate and 10 feet from third base. What is the distance of the throw to the nearest tenth? So the very first thing I need to do is I need to figure out what information I can put on this diagram. So you notice that home plate is located here. The throw occurred, it started at first and went over to third, but it says it's 10 feet from third base. So I'm going to go ahead and put a point 10 feet from third base, which would be right there. And they gave me the coordinates of third base at 0, 90. So that means that that point has to be at 0, 80. Okay, so hopefully you're seeing that same right triangle. If I map the distance of that throw right there, so there's my right triangle. So from home plate up to where the pitch or the throw was is going to be equal to 80. And from home plate over to first base, you can see is 90. So I can use the same thing that I've been doing. Now these numbers are a little larger, but you have a calculator. So I'm going to take the square root of 80 squared plus 90 squared in order to find that distance. So I have 6,400 plus 8,100. I'm going to take the square root, which gives me 100. So we have 14,500, which is what we're taking the square root of. So I'm going to put that in my calculator, and I'm going to round to the nearest tenth, which would tell me that that throw would have been approximately 120.4 feet. Now this video will be here all the time. So we watched this in class. Your teacher, which is either myself or Miss Sykes, we've been stopping it. We've been talking to you about what to write down, modeling how to take notes by watching the video. But just know that this is always here. So if you're coming up to a quiz and you want to go back and review, you can go back and watch this video again. If you're coming up test time and you realize as you're working a review that you don't remember distance or midpoint or whatever the case may be, you can always come back and watch this video. You can pause, you can fast forward, you can watch certain parts. So that is one of the values of the flipped classroom. So if you have any questions today in class, we're here, we can answer them. But just know that you will be doing this on your own, hopefully, by next week.